Today we have a topic of surface area of a cone and surface area of a cone and volume of a cone. So, volume of a cone is nothing but 1/3 of volume of a cylinder. When we fill 3 times with a radius r and height h, with the same radius and height of a cylinder, then it takes 3 times to fill the cylinder completely. That's why we can say that 1/3 of volume of cone is equal to volume of a cylinder. So let's see some question. The base radii of two circular cones of the same height are in the ratio 3:5. Find the ratio of their volume. So R1 is equal to R2 and ratio of H1 is to H2 is 3:5. That means H1 is 3x, that we consider H2 is 5x. And we need to find out volume of this. So, volume is 1/3 pi R1 square into H1, same as 1/3 pi R2 square and H2. 1/3 pi, 1/3 pi is going to cancel, and R1 and R2 is also going to cancel because R1 is equal to R2. So H1 upon H2 becomes 3/5. So ratio becomes V1 is to V2 is equal to 3:5. That is our V1 and that is our V2. Another question, a right triangle ABC. We have a right triangle ABC. This side 5 centimeter, 12 centimeter and 13 centimeter. And this is our longest side, so we can say that revolve about the side 12 centimeter. That means it's become our 12 centimeter. And it's become 5 centimeter. Find the volume of the solid so formed. And we know it's become our radius and it's become our height. So R1 becomes 5 centimeter and H1 becomes 12 centimeter. So volume becomes V1 is equal to 1/3 pi R1 H1. Yes. If the triangle ABC is revolved about the side 5 centimeter, now triangle ABC revolved about 5 centimeter and in a view. So in a V2 we have a R2 is equal to 12 centimeter and H2 is equal to 5 centimeters. So V2B is equal to 1 upon 3 pi R1 square H1. This is pi R1 square. Find the ratio of the volume of the two solids of time. So V1 upon V2, we need to find out V1 upon V2. V1 upon V2. So we need 1 upon 3 pi is going to cancel, 1 upon 3 pi is going to cancel. So we get 5 square into 12 and 12 square into 5, 5 cancel. So V1 is 2, V2 is equal to 5 is to 2. Another question. A cone of radius 5 cm is filled with water. If water poured in a cylinder of radius 10 cm, the height of water rises 2 cm. Find the height of the cone. So, a cone of radius R1 is 5 cm and we need to find out H1. And when we talk about cylinder, then the radius 10 cm and H2 2 cm, that is versus radius up to 2 cm. So, and we know volume of cone is equal to volume of water. Volume of cone is equal to volume of water, and water is inside cylinder. Water is inside cylinder, so we easily say that 1 upon 3 pi R1 square H1 is equal to pi R2 square into H2. Pi cancel. So 1 upon 3, R1 is basically 5 into 5. H1 we need to find out. R2 is basically 10 into 10 and H2 is 2, and we cancel this. So H1 becomes 24 centimeter. So height of cone is 24 centimeter. In another question, a cone and a cylinder are having the same base. Find the ratio of height. Find the ratio of their heights if their volume are equal. That means a cone and cylinder same base. That means R1 is equal to R2 and V1 is equal to V2. It is also their volume is equal. So we can say that 1 upon 3 pi R1 square H1 is equal to pi R2 square into H2, and we need to find the ratio of their height. So pi cancel, R1 R2 cancel, both of them are equal. So we can easily say that H1 to H2 is equal to 3:1. So Next we need to find out. In another question, a solid cube of a side 7 centimeter is melted to make a cone of height 5 centimeter. Find the radius of the base of the cone. So that's mean the volume of cube is equal to volume of cone when it's going to be melted. That means volume of cube is equal to volume of cone. So volume of cube is what? 7 into 7 into 7. And volume of cone is what? 1 upon 3 pi r square x. That means, and we have a given x is equal to 5. So 7 into 7, 7. 1 upon 3. 12 upon 7. R square into 5. So we can easily say that R square is equal to 7 into 7 into 7 into 7 into 3 upon 22 upon 4. When we find out this, we get a radius of cone. In another question, from a right circular cylinder with a height 10 centimeter and radius of base is 6 centimeter, a right circular cone of the same height and base is removed. Find the volume of remaining solid. Suppose we have a right circular cylinder with a height 10 centimeter and radius 6 centimeter. A circular cone of a same radius and height is going to be removed. That's mean that's mean its height is 10 and radius is 6 is going to remove. And we need to find out the remaining solid after removing of cone from cylinder. There is some solid left during removing of cone. So it's going to be, suppose we need to find out the volume of the remaining solid. So we can say that volume of cylinder is V1, that we consider, and volume of cone is V2. When we subtract it, we get volume of remaining solid. And let volume of cylinder is X and volume of cone is X upon 3. And we know volume of cone is 1/3 of volume of cylinder. So X minus X upon 3. It becomes 2X upon 3. That means, otherwise we can also say that V and V upon 3 we get V. And this is the remaining volume of the solid. Remaining remaining volume of 2 into 3 upon 2. And V is basically what? Volume of cylinder. Volume of cylinder. So, volume of cylinder. And we know remaining volume of solid is 2 upon 3V. So we can directly do 2 upon 3 into pi r square h. And radius is same, base is same, that doesn't any involvement of theta in this question. So 6 into 6 into 10. So easily find out the remaining volume of the cylinder. Otherwise, we can also find out like volume of cylinder is what? Pi r square h minus volume of cone is what? 1 upon 3 pi r square h. Just now we are volume of cylinder is what? This. And again, this is the volume of cylinder. Just we need to 1/3 of V upon 3. We get the remaining solid. In another question, find the volume of the largest right circular cone that can be cut out of a cube whose area is 9 cm. We have a cube of area 9 cm and we need to cut out a cone of largest size. That's going to be assumption wise that we consider the largest diameter of cone is 9 cm. Largest diameter of cone is 9 cm and the height is 9 cm. We have a cone this which has a height 9 centimeter and radius 9 upon 2. That's it. Radius is 9 upon 2 and diameter is 9 centimeter. So, and the volume of the largest circular cone, that's 1 upon 3 pi r square h. So 1 upon 3, 22 upon 7 into 9 upon 2, 9 upon 2 into 9. A conical tent is 9 meter high and the radius of its base is 12 meters. What is the cost of canvas required to make it if a square meter canvas costs to 10 rupees? A conical tent is 9 meter high and the radius of its base is 12 meters. A conical that is 9 meter high and radius is 12 meter. So we know what is the cost of canvas required to make it at making of this. We need to find out the lateral surface area of cone. That is pi r. Lateral surface area is pi r, and we know if a square meter canvas cost, if a square that is meter square and a meter, 1 square meter cost is 10 rupees and we get pi r that meter square. So when we multiply with 10, we got a cost of canvas required to make it. Now, in another question, in another part, how many person can be accommodated in the tent if each person requires 2 square meter on the ground? On the ground, 2 square meter. On the ground, and 50 meter cube of a space to breathe, and in space we need 15 meter cube. So suppose when we talk about when we have a simply ground, there is a no lateral side, so we have a just carry 2 square meter on the ground, each person 2 meter each square on the ground, and that is 1/3 pi R1 pi R1 square upon h. So how much volume is going to on the ground? Upon when we have a tent with a height this, we have a h height, so 9 meter, so this is going to 1/3 pi R2 square into H2. So I will divide it by 50 and divide, basically radius and height is same in both the cases. That doesn't matter. R1 is equal to R2 and H1 is equal to H2. So in this case, we can't completely say that we doesn't require of this. Basically, when we doesn't mention this, height is not available in this. So we directly say 1/3 pi R2 H2 50, and that's the least in both of them to define the person accommodated in the stand. So this is the case